Today I'm going to show you guys how to find the derivative of y equals arcsine of x. Arcsine is also sometimes called sine inverse. I'm going to use the terminology arcsine instead of sine inverse. But you sometimes may see arc cosine, or arcsine written as sine inverse x or sine negative 1 x. These two things they mean the same thing. So first of all, we're going to use implicit differentiation in order to find the derivative of arcsine. And we start off by our given function y equals arcsine x. What we want to do is sine both sides of the equation. So when you do that, you get, and from this equation that leads us to this equation. And with this equation you have sine y equals x. So here is where we're going to start, and we're going to now from here we're going to differentiate both sides with respect to x. So we're going to ddx both sides, or differentiate both sides of the equation with respect to x. And I'm going to switch slides here and rewrite sine y equals x. Now here I'm going to put an asterisk by this, and we'll come back to this later. Let me put two asterisks here, because this is going to be something that we are going to come back to later on in the problem. From here, differentiate both sides with respect to x. And the result, using implicit differentiation now, you cannot take a derivative of sine y with respect to x without attaching a dy dx. So when I do that, I'm going to differentiate and attach dy dx. And the derivative of x is 1. So here now is I'm going to find dy dx is what I'm searching. So solving dy dx, divide both sides cosine y. From your trig class, you should have been given a Pythagorean theorem, a very important theorem in trigonometry, but as used here, whenever you have the theorem says that sine square theta plus cosine square theta equals 1. Solving for cosine of theta. So you get cosine of theta equals 1 minus sine square theta. Well, theta is just a what you would call a dummy variable. If there was a y there, you could interchange the y's. So sine square theta, you could write sine square y plus cosine square y equals 1. And if we did that, we would come down to the final answer, which would be cosine of y, and I'll draw a line here. So you get cosine y equals square root 1 minus sine square y. Cosine y equals this value. Cosine y equals square root 1 minus sine square y. Let me write that a little clearer. Cosine y equals square root 1 minus sine y value square. That's what sine square y equals. Sine square y is sine y value square. So if I know what sine y is equals to, I can substitute. Well, sine y equals x. So since sine y equals x, I can plug that there and then substitute for cosine y. I'm going to go to the next slide. So here's where I left off. And we also said that, and we know that sine y equals x. So sine square y equals x squared. So we can substitute that. And you get that dy dx dx equals 1 over 1 minus x squared. So recapping, if y equals arcsine x, then dy dx equals 1 over the square root of 1 minus x squared. And the chain rule tells us that if y equals arcsine of u, where u is a function of x, then dy dx is 1 over the square root of 1 minus u squared multiply du dx. In the next video, we'll look at examples of finding the derivative of arcsine of functions.